Hello students, how are you? Myself Jamin Patel. Today we again meet for our online session. I hope you all are safe at your home and updating your 10th standard knowledge. Now today in science subject I will take the physics portion. In physics one important chapter is that is the electricity. If fundamentals of electricity is cleared, then definitely this chapter is very easy to understand. Today we will discuss about the introductions of the electricity. So students, if we talk about the our time of our grandfathers or before that, so electricity was a part of a luxurious life. Okay, if the electricity is available at any home on that time, then it will be considered as a luxurious life. But nowadays electricity has become a necessity. We cannot what you can say, we cannot imagine our life without the electricity. So electricity is become an important part of our life. Now here we are familiar with these terms electricity. Now what is the meaning of electricity? So in simple sense we can say is that electricity means the study of charges. Different type of charges, the positive charges, the negative charges, the study of this all the charges and behavior of this all the charges, that is nothing but the electricity. If we talk about the type of electricity, there is the two type of electricity is there. One is the static electricity and second one is the dynamic electricity. Now what is the difference between these two electricity? Static electricity means when the charges is remain steady, when the charges is in the rest conditions, charges is present at one pole only, one end only, and it will provide the effect, then this type of electricity is called as a static electricity. And if the charge is in the moving conditions, then this type of electricity is considered as a dynamic electricity. Now here how the electric charge, presence of electric charge can be judged. So here simply if we take the dry, means if we take the comb and if we rub the comb on the dry hair and later on if we keep the comb nearer to the piece of paper, so we all are aware that the piece of paper is attracted toward the comb. The same another example is there, the glass rod is rubbed with the silk, later on this glass rod can also attract the papers. Plastic rod is rubbed with the fur, it can also provide the attractive force. So these all are example, this all the activities, this all the example can give the idea about the presence of charge. Okay, it may be positive charge, it may be negative charge. So in this process the charge result on the glass and plastic are of the opposite types. Okay, so during the friction glass rod acquired the positive charge while the plastic rod acquired the negative charge. So from that basis we come to know two type of the charge involved. Okay, one another simple example is that, okay, I think so you all are familiar with that. In winter seasons when we suddenly sit over the plastic chair, sometimes we feel the current. So that current is the static electricity. Okay, so that is due to the accumulations of charge at any pole, at any end. So it is nothing but the type of static electricity. In this chapter our main focus is on dynamic electricity, not a static electricity. Okay, so here two type of charge is present, positive electric charge that is produced due to the proton and negative electric charge that is produced due to the electron. Here now electric charge is the intrinsic property of the electron and proton. Now what is the unit of the charge? So charge is generally measured in Coulomb. Now it is for the proton also, it is for the electron also. Now we already study in the 9th standard that the number of electron and number of proton in atom is remain same and atom is electrically neutral. Atom is electrically neutral. So in from that statement simply we can judge that the charge of both the proton and electron is same but in opposite sign. Okay, so if we talk about the charge of proton, so that is 1.6 into 10 raised to minus 19 Coulomb. if we talk about the charge of electron is also 1.6 into 10 raised to minus 19 coulomb, but here electron charge is negative. Electron charge is negative, while the proton provide the positive charge, but the charge quantity of one single proton is very less, that is the 1.6 into 10 raised to minus 19 coulomb. Okay, so here this is about the charge of the electric charge of proton and electron. Now this electric charge is responsible to produce the current. Okay, so here before going to electric current, first we will understand what is the meaning of electric circuit. Circuit means what? Circuit means simply here closed, continuous and closed path of electric current is called as the electric circuit. This is considered as this is nothing but considered as a one electric circuit, means is the closed part and continuous part, means there is no breakage. Here continuous connection is there. If the continuous connection is made, then it will form the circuit. Here if I kept this switch off, then circuit is break, so current will not flow. If we make the switch on, then again continuous circuit is formed, and again continuous circuit is formed, and this electric current will pass from this circuit. So here electric circuit means a continuous and closed path of electric current is called as the electric circuit. Now students, one interesting thing is that when the electricity was discovered, on that time discovery of electron was not done, means discovery of electricity is before the discovery of electron. So in past when the electricity was discovered, on that time thinking was false thinking is there. Definitely it was false thinking, but thinking was electric current was produced due to the flow of positive charge. Electric current was produced due to flow of positive charge. Later on the electron was discovered, and electron was discovered by the scientist J.J. Thomson. Later on different scientists come to know electricity is produced due to the flow of electron, but already the concept was established, that is the directions of electric current, that is same as the directions of flow of positive charge. So directions of flow of positive charge is considered as the directions of electric current. Okay, so this concept was already established, it is already printed in all the books. So scientists, when the scientists come to know the directions of flow of electron is different, is in opposite directions, so they are not going to change the directions of electric current. They are not going to change the directions of electric current. They just gave the statement that the directions of flow of electron is opposite to the directions of electric current. So till day also the directions of electric current is from positive end to negative end, is from positive end to negative end. It is from positive end to negative end, that is the directions of electric current. But we know that the directions of electron, that is from negative to positive, it is from negative to the positive. So here conventionally in electric circuit the directions of electric current is taken as a opposite to the directions of flow of electron. So here this corrections is made. Okay, here the direction is not going to change, the directions of electric current was same as from positive to the negative, but when scientists come to know the current is produced due to the electron, they just gave the corrected statement, that is the directions of flow of electron is just opposite to the directions of electric current. Okay, so here till date also the directions of electric current, that is from positive to the negative. So listen student, okay, make note this: the directions of electric current and directions of flow of electron, both is opposite. Both is opposite. Directions of electric current is from positive to the negative, while the directions of flow of electron, that is from negative to the positive. Okay, now here we know that the metal is capable to conduct the electricity, to produce the dynamic electricity. Now in atom, the electron move around the nucleus where the proton remain binded, right? We know that, we already discussed in the structure of atom in 9th standard. The atom, in atom the electron is moving around the proton and is binded, means is in moving conditions. Now during the formations of metallic material, this electron gets separated. Some of the electron get separated, means the electron present in the valence orbit get separated from that parent atoms and move random manner, move random in manner. Such electron are known as a free electron. See here, see here, this electron, it is moving in the random manners. Okay, in presence of electric field they move in the same direction, but in absence of the electric field they move in the random manner. So here this electron is considered as a free electron. This electron is considered as a free electron. Okay, so such free electrons are responsible for the conductions of electric current. So in metallic material like the copper is there, silver is there, aluminum is there, possess the number of free electrons, and that's why this metallic component is considered as a conductor. This metallic material is considered as a conductor. And the material like the rubber is there, glass, plastic, do not possess this free electron, and that's why this material is considered as a insulator. So we can classify the material as a conductor, as an insulator on the basis of this free electron also. Now here this free electron, as we discussed previous, this free electron is move random manner, okay. Due to the random motions of free electron at any interval of time, the number of electron moving in the right directions and number of electron moving in the left direction from any cross section area is 0. Means net quantity of electric charge passing through the cross section area is 0. See here, this one is the one flow chart is there. Now here the number of electron, if I take any cross section area, so number of electron moving in the left directions and number of electron moving in the right directions. Okay, here suppose the 10 electron move, suppose the thousands electron moving in the left directions and thousands electron moving in the right directions, but total net quantity moving in particular directions is become a 0. Why? Because the thousands in left and thousands in right, so net quantity is 0. So here in random movement we observe that the net quantity of electric charge passing through the cross section area is become 0, and that's why we feel that when the metallic conductor, metallic material, metallic wire is not connected to any battery, on that time is not capable to produce the current. Okay, we observe that simple piece of wire is there, suppose the copper wire, piece of copper wire is there, if we placed on the metal, if we place over the tiles, and if we touch this wire, free wire is there, if we touch the wire, so can we feel the current? Definitely not. We cannot feel the current, even though that free piece of copper wire possesses the free electron Why we cannot feel the current? Because this free electron is in the random motion, and when the electron is in the random motion, then this type of electron cannot produce any current, cannot create any current. If this all the electron is in the same direction, if this all the electron move in the same directions, then only they can produce the current, otherwise they cannot produce the current. So therefore the electron, this electric current is not formed even though they are in, there is a motion of free electron in conducting material. Now if any energy is provided to the conducting wire through the battery, otherwise through the AC current, through the DC current, the flow of electron, flow of this free electron can be obtained in the conducting wire from negative to the positive terminal of the battery. See here like this, here this one is the negative terminal and this one is a positive terminal. So when the battery is connected to this wire, so definitely battery will provide the energy, and that energy, it is nothing but called as a potential difference, that we will discuss later on. This energy is provided by the battery, and due to that energy, electron that is in the random motion, in previous case this all the electron now is move in particular direction only, they move in the particular direction only, and that's why this type of conducting wire can produce the current. This type of conducting wire can produce the current. So when the battery is connected, the movement of electron from negative terminal to the positive terminal, thus the net quantity of electric charge passing through the cross section A does not remain zero, and it can produce the current. Okay, so here I think so you come to know how the current is going to produce. So if we talk about the definitions of the current, simple definitions of the current, so simple definition is that it is the rate of flow of electric charge. Why? Because the electron is going to move and electron possesses the charge. So it is the rate of flow of electric charge that is called as the electric current. It is a silly simple definitions of the electric current. And if we talk about the defined, matlab in-depth definitions of the electric current, then net quantity of electric charge that is flow through any cross section area of the conductor is known as the electric current. Once again, net quantity of electric charge flowing through any cross section of the conductor is defined as a electric current. Okay, so here means electron is going to move from negative to the positive, and that electron possesses the charge. So net quantity of electric charge that flow from any cross section area is called as the electric current. Okay, if we talk about the calculated terms, then if the net charge is Q that flow through the any cross section area in time t, then current I is going to produce. Current is denoted by the I. Current is denoted by the I. So I is equal to Q by T. I is equal to Q. Q means the net charge that is flowing from the conductor per unit time. Okay, so here if we talk about the calculated equation, means the equation form definitions of the electric current, then the I is equal to Q by T. I is equal to Q by T. Here the Q is charge that is provided by the electron, and time T is measured in second. So SI unit of the electric charge is Coulomb, that we already discussed in the previous session, means in the previous topic. So unit of electric charge is Coulomb. Now if we talk about the quantifications of the Coulomb, so 1 Coulomb is equal to charge of 6 into 10 raised to 18 electron. We already discussed that one electron possesses 1.6 into 10 raised to minus 19 Coulomb charge, one electron. So in this way 6 into 10 raised to 18 electron is collected, 6 into 10 raised to 18 electron collected, then the charge is equivalent to 1 Coulomb. So 1 Coulomb is equal to charge of 6 into 10 raised to 18 electrons. Okay, so here electric current is expressed by the unit of ampere also. Okay, in honor of scientist Andre Marie Ampere. Okay, so here till the unit of till the unit of current is Coulomb. Okay, is charge is measured in terms of Coulomb. Here it is time is measured in terms of second. So unit of current is Coulomb per second. Unit of current is Coulomb per second, and this Coulomb per second is called as a ampere, in honor of scientist this Andre Marie Ampere. This Andre Marie Ampere discuss the concept of electric current, generate this concept of electric current. So in honor of this scientist, now the Coulomb per second is called as a 1 ampere, is considered as a 1 ampere. So here the unit of current is 1 ampere. Sometimes minor electric current is required for some of the device. Suppose for example, if you talk about the charging of mobile, so whatever the current required for the charging of mobile is very minute, so on that case is the ampere unit is comparatively large. So some small unit is also required to express this current. So milliampere charge is there, microampere is there. Okay, just see your charger, mobile charger. Okay, you will observe that the current is in the milliampere form, it is not in ampere form. Milliampere current is written on the charger. Okay, so here the small quantity, another small quantity, but the SI unit is fixed, that is the ampere. Additional small quantity units of the current is milliampere as well as microampere. 1 milliampere is equal to 10 raised to minus 3 ampere, and 1 microampere is equal to 10 raised to minus 6 ampere. Okay, I think so you come to know the unit of current. Now here this one is the closed circuit. Now in this closed circuit, if the battery is connected, current is passed from this circuit. Now how to calculate the current? Okay, whether the 1 ampere current is passing, or 2 ampere current is passing, or 3 ampere current is passing, or 1.5 ampere current is passing, how we can calculate the current? So special instrument is used to measure the current. That instrument is called as a ammeter. This instrument is called as a ammeter. So this instrument is used to measure the current passing through the circuit, and this instrument is always connected in series. This instrument is always connected in series, in circuit. Understand? So ammeter is used to measure the current that is passed from the circuit. Understand? Now here one additional part is that is, if the number of electron passing through the cross sections of the conductor in time t is equal to n, then the quantity of charge that is passing through the cross section area will be q is equal to ne. Okay, q is equal to charge, right? Now n is the number of electron, and E is the charge of one electron, that is a 1.6 into 10 raised to minus 19 Coulomb. So Q is equal to number of electron into this charge, so definitely it will give the value of Coulomb. So we can replace the Q by the Ne also. Okay, so this equation used is important, otherwise is beneficial when in any numericals, if the question asks for number of electron, then we can use this equation to calculate the number of electron. I think so you are familiar with this, means you can understand about the electric current. What is the electric current? Now how this electric current is produced, which energy is provided, that potential difference, that we will discuss in next lecture. Here on the basis of this equation we will solve one sum. Here this one sum is that current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flow through the circuit and calculate the number of electrons that pass in that time period. Okay, so here simple, which component is given here? So here I is given, I is equal to 0.5 ampere, right? Second things is given, that is the time t is given, that is the 10 minute, and we already discussed that time should be calculated in terms of second. So 10 into 60, that is the 600 second. Now amount of electric charge means the questions ask, that is the q is required to be determined. So how we can calculate the q? So I is equal to q by t, right? So can I write q is equal to I into t, right? So q is equal to I is 0.5 into 600. 0.5 means we can say is that 1 by 2. So 600 divided by 2 means the 300 Coulomb. So q is equal to 300 Coulomb, right? Q is equal to 300 Coulomb. So this one is the answer of first question, that is the find the amount of electric charge that flow through the circuit. Now additional questions that added by me, that is not a part of actual questions, that is calculate the number of electron. Calculate the number of electron here. So number of electron, so we already discussed that the q is equal to Ne, right? So number n, so n is equal to q by E, right? Q that we already calculated, that is the 300, E that is the 1.6 into 10 raised to minus 19. So can I write in this way, 300 divided by 1.6 into 10 raised to 19, 10 raised to minus 19, that is come upward, so it is become 10 raised to 19. Now 300 divided by 1.6, do it. 300 divided by 1.6, that is 1.87, sorry 187, 187.5 into 10 raised to minus 10 raised to 19, right? Now if I make 1.87, then 10 raised to 17 is there. So number of electron pass in this time period, that is 1.87 into 10 raised to 17. I think so you are clear with this sum, right? Okay students, now we stop our topic here. We will meet you with the potential difference in next lecture. Okay, thank you very much.